Good afternoon. This is David Eastwood, Geotech Engineering and Testing. How y'all doing? Thanks for taking the time to listen to this webinar. Let's see if we can get this going. Today, what we're going to be talking about design and construction of clay liners for detention ponds. God, we do a lot of land development projects, and we do a lot of stuff for a lot of the municipalities and agencies, Harris County, cities, and of course, a lot of land development projects. And clay liner is a big deal with some of these wet ponds and recreational ponds. So I've done some research and testing, and it seems like there's not a whole bunch of information out there. So I just thought, put it all together. We have about 200 people RSVP'd, and we have a lot of developers, home builders, a lot of people from different cities all over Texas, a lot of engineers, civil engineers, land development engineers. You need to reach me. My email is de@geotecheng.com. My number is 713-699-4000. We're going to put this on YouTube so you can have yourself or your staff can go watch it again, so that you have access to it. We've been in Houston for about 39 years. We do geotechnical, environmental materials, and geoforensic engineering. We have a staff of 60 engineers, technicians, and support staff, and we work all over Texas. We have our own rigs, so we can mobilize into projects quickly. So Geotech's been around for a long time. So if you have any questions, go ahead and type your questions in, I guess, Q&A or chat, and I get to it as soon as I see the question. When clay liner may be required. I mean, when you're doing a commercial or residential project or industrial project, and if you got sandy soils, then you may need a clay liner to get these ponds, keep it wet, have a rec center, or there's a beautiful commercial facility here, a bunch of restaurants here out there in northwest Harris County. And they definitely want water in their pond. Kingwood, they've got a wet pond there. A lot of residential developments. And they need to have ponds and want to keep water in them. A lot of land development projects. This is a beautiful pond there. I think this is in Fulshire, if I'm not making a mistake. Fulshire place, so out there. It's another detention pond. Commercial. That's in near Valley Ranch, if I remember right. That's I-10 near Beltway 8, and those offices out there. And see, I mean, there's all kinds. This is Sugarland, I think. Tavola. Out there on 59 North. Industrial ponds. They need to have ponds with clay liners that hold the chemicals in the pond. So we run into clay liners for some of these industrial ponds. That's out there on 225 out there going east. Clay liner design. I guess to design a clay liner for your pond, you can see the clay liner here on the natural soil. You got to test the soils to see if the soils are real sandy or dispersive. At that point, you're going to need a clay liner. For a regular wet pond, if you have kind of a detention pond, you got to do Borings for your detention pond. You got to do one boring every 1 acre to a depth twice the height of the pond. So you send a truck rig or a buggy rig and make sure you get the soil samples. If your soils are sandy and you want to have a wet pond, and at that point, then you may have to use a clay liner. Borings for channels should be at 500-foot spacing to a depth twice the height of the channel. So if you have a channel, you do the borings for it. Twice the height of the channel. You do a bunch of lab testing, of course, to classify the soils. You've got liquid limit test. This test, you want to know how much water you should add to the soil for it to behave liquid. You add, you get a soil, you add water to it, you put it in this cup, and add water to it. When it becomes liquid, you get a soil sample with this spatula, put it in this cup, and you cut a groove through it, turn this handle 20 to 30 times. When it comes together, you get a sample of it, and you put that sample in a cup like this, you get the wet weight of it, and then you put it in the oven and dry it up, and then you get a dry weight of it, and you know how much water is in that soil for it to behave liquid. It's kind of a basic soil test. And plastic limit test. In this test, we want to know how much water we should add to the soil for it to behave semi-plastic. And we get a soil, roll it to 1/8 of an inch, and you get the wet weight of it. You put it in a cup like that. You put it in the oven, dry it up. You get the dry weight of it. And that's the difference between that is, of course, is how much moisture is in that soil for it to behave semi-plastic. Difference between liquid and plastic limit is PI. PI less than 20 is low swell potential. It's not a good material for clay liner with PI less than 20. 20 and 30 is moderately expansive soil. It's really not a good material for clay liner. 30 to 40, you got highly expansive soils, and that's a good clay liner. And above 40 is even better. Very high PI, and of course, it's a good clay liner. Couple other tests when we do all these detention ponds and clay liners. We do a hand penetrometer and a torr rain test. In a hand penetrometer, you push this thing into the soil, and you can read here what kind of strength it has. Torr rain, you put it at the end of the sample, and you turn it here and shear the torsion and get an estimate of the soil. We want to know what the strength of that clay liner is. Gradation is really important. Run sieve analysis. You put the soil in here, and of course, you get a gradation in here. You look at the -200 in here, see how much it passes. 70% passes. So this is lean clay, sandy lean clay. So that's a good material for clay liner. You typically want a material that for clay liner that's got, PIs of, liquid limit greater than 30 at least. In general, if you have gravel, that's not a good material for clay liner. It has to be smaller than 3 inches. Sand, not good material for clay liner. Smaller than 0.187 inches. Silt, less than 0.075 millimeters. And silt is not a good material for clay liner, but clay is. Clay liner for dispersive soils. We have dispersive soils throughout the Harris County, Fort Lee County, Galveston County, Brazoria County, Waller County, Galveston County. These dispersive soils are the soils that are easily erodible, and they start eroding when they get wet, and so you can see the channels here that got erosion is the dispersive soils. They got jug holes in here. You can see that, like that. A lot of erosion. You have dispersive soils. See the dispersive soils, a pond in here. They got dispersive soils, and you got basically failure. This is the pond out there near Veterans Memorial and Beltway 8. A lot of erosion out there. They had these jug holes out there along the detention pond right there at the top. Cops were chasing somebody. They fell into it, and the guy broke his back. dispersive soils. To know if you have dispersive soils, you can run crumb test. You get soil sample, 3/8 of an inch. You put it in the water. If it's not cloudy, the soils are not dispersive. If it becomes cloudy, the soils are dispersive. If you got dispersive soils, obviously you want to put a clay liner on it. You also do pinhole test. Basically, you got this standpipe in here. You put a head of water. You put a soil sample in here. You poke a hole in it, one millimeter. If the water that's coming out is clear, the soils are not dispersive. If it's cloudy, the soils is dispersive. And the pinhole test got a rating. If the rating is D1 and D2, these soils are dispersive enough to require a special design. If they've got ND1, indicates the soils is not dispersive. And if they're ND2, ND3, or ND4, indicates the soils are slightly dispersive. You may want to do other tests just to make sure it is dispersive. And if they are, then of course you use a clay liner to kind of stop the dispersive activity. You can also do double hydrometer tests. That's what some of the agencies like. You get a regular hydrometer test. You add water to the soil, and of course, you let it disperse. And you have another hydrometer test where you actually put chemicals in it, a standard hydrometer, and put dispersive agents, sodium hexametaphosphate, and then you get those gradations. And based on the gradations, you can estimate if the soils are dispersive. You get the percent passing 2 microns. In this case here, for this one here, it's soil with dispersing agent is about 75% passing. And here with the soils without any dispersion, it's about 16. So you get a ratio of that. It's about 16% moderately dispersive soil. Yeah, dispersing agents, that you get a percent dispersion of a clay of 2 microns without dispersion over the one with the dispersing agent. If the number is less than 30, your soil is non-dispersive. Between 30 and 50 is intermediate. Greater than 50 is dispersive. So percent dispersive greater than 50, the soil is probably dispersive. Less than 30, the soil is probably not dispersive. And being 30 and 50, you may want to run other tests. How to repair dispersive soils? You can remove all the dispersive soils and put non-dispersive soils on your channels or detention ponds. You can lime stabilize and put the material back in, kind of expensive. And so that's one option. And the other option is to put a clay liner. We see a lot of clay liners. People just go put a clay liner over dispersive soils. Keep the surface of the channels, water from coming in over the channel, so that doesn't erode. So you put like a swale in the back of your channel here so that the water does not have to go over the slope face. Here's a detention pond in here where here's a pond in here, and they've got the back of the pond. They got this swale that's got an outfall into the pond itself, so water doesn't have to go over the slope. Clay liner design, typical clay liners are about 2 foot thick, maybe 3 foot thick. I've seen them as thickness of 1 foot. So, you want a permeability, maximum 10 to the minus 7 centimeter per second. The one I like is liquid limit greater than 50%, passing number 200, 65 to 100%, non-dispersive, minimum thickness 2 feet. Compact 95% standard proctor at optimum plus 3%. Key into the existing, of course, slope to seal and prevent leaking. Yeah. So this is the clay liner. You got subject to hydrostatic pressure. So if you got a pond, you go out there. Of course, if there's no water, you excavate it. And you put your clay liner in and you fill it up with water immediately. If your soil got groundwater problem, you got to do de-water. Put the clay liner in, and after you de-water, you put the clay liner in. You add the water in there, and of course, stop the dewatering. So Otherwise, the hydrostatic pressure is going to blow up the clay liner. So that's very important. TCEQ clay liner specifications. Now remember, this is the one I recommended. Liquid limit greater than 50. Percent passing number 65 to 100. Permeability maximum 10 to the 7 centimeter per second. TCQ clay liner recommendations that they said liquid limit greater than 30, 30% passing number 200 sieve, PI greater than 15. Minimum thickness 2 feet, and permeability 10 to the minus 6 centimeter per second, which is, sometimes it may not hold. That's kind of like sandy soil, sandy clay. Okay. So I don't recommend it realistically. I don't recommend this TCQ clay liner spec. Here's Florida clay liner. They say liquid limit greater than 30. Greater than 30% pass number 200. PI greater than 15. Compact 95%, 2 foot thick. Permeability 10 to the minus 7 centimeter per second. Georgia, same thing. It's not everybody's stuck on liquid limit greater than 30 percent passing number 200. PI greater than 15. I think these are conservative values by Florida, Georgia, and TCEQ. So the one I like is the one I recommend is with the liquid limit greater than 50. Of course, if you put a clay liner in, you don't let the pond sit empty for more than 14 days. If you put a clay liner in, you got to put the water in. Otherwise, it's going to develop shrinkage cracks, and it's not going to hold water. And we see that on some of the detention ponds that they let them sit for a long time. They put the clay liner in, then they put water in it. They find out why it's not holding water. This shrinkage cracks are not any good. We don't want that. Construction construction of the clay liner. Of course, first you got to go out there and dig your pond. So we start digging the ponds, removing the soils, grade it and all that. Compact it. Get your channel ready. You bring a clay if you need to for the clay liner. Bring it in and start spreading it. You may have to go import clay. I mean, if you're out there in Fort Bend County, Rosenberg area, or out there in Pearland or Liberty County, most likely you're not going to need anything in terms of bringing clay. But if you're out there in Katy area, 249 area, 290, all that northwest Harris County, where you got sandy soils, in those areas, you may not have enough clay. So you're going to have to go out there and import clay. And you go to a pit. Pit's got different type of soils. You got sandy soils here. You got clay here. And you dig out the clay part. And that's a good clay there. You put it in the back of the truck and haul it to your job site. And of course, you're going to make sure, your clay liner, you've got a high PI soils. You get that material, you break it up, of course, to run a Proctor test on it to get the optimal moisture and dry density for your compaction. You got to make sure the clay liner is compacted 95%. You chop it up and add water to it at different moistures. You compact it with the standard Proctor 5.5 pound hammer, drop 12 inches, 3 layers in a 4-inch container. So that's it, how the machine compacts it. Then you move the mold out there. Here's your compacting it. You know the volume of the mold. And you weigh it. So you know the weight, you know the volume, you get the density, you get this curve here. This is the optimal moisture. This is if your soils are too dry, You got lower density. If the soils are wet, you get lower density. So you want to compact optimum plus 3% for your clay liner. So moisture would be between 11 to about 14%, compacting 95% of standard Proctor density. So if your maximum dry density is about 122, your 95% is about 115 pounds per cubic foot. So that's what you would be looking for. So you bring in the clay, you start spreading it. You do the grading. And you start compacting it. Well, I guess you got to check the moisture. If you need to add water to it, again, you want to compact it on the wet side of the optimum. You add water to it, compact it. Make sure the clay liner is compacted pretty good. You put it in 6 to 8 inch lifts, and you got to run density tests for every lift. So you got to make sure you got 2 foot of clay liner. So you're going to have essentially 3 lifts. You got to proof roll the bottom of the pond. Make sure it passes density and compact it. And then run density tests on the subgrade. Then as you bring in the fill, you run density on every lift. Now, in the areas where you got an outfall coming into the detention pond, we double the clay liner thickness. So if you're typically 2 foot clay liners near the outfall areas to prevent leak, I usually say within a width of a sheep's foot or a dozer, 8 foot or so, 6 foot, go 4 foot clay liner. So that just you have a little factor of safety against leaking. Of course, you run density tests for every lift. So run densities every lift. This is your Proctor curve that you run. In this case, you got a Proctor soil with the liquid limit 65, plastic limit 21, PI of 44. That's a good material to have as for Proctor. The maximum dry density is 92.8. And of course, optimum moisture is 25. So you want to compact it 25 plus 3. So that's 28%, and 95% or 92, somewhere about 89 pounds per cubic foot for the clay liner. So you go out there and you put the first lift, second lift, you run the densities, make sure they all pass. You go all the way out there on all the densities out there for different locations. This is again first lift. Then you go to the final lifts. Makes all the lifts pass. These are the detention pond, and these are the location of various densities we're taking. Then at the end of the job, you do a closure letter saying that but basically the densities were all the densities passed, and there was like 2 foot of clay liners were placed. Sometimes we get jobs where the clay liner is already placed. They want us to verify the thickness of the clay liner. So we get a backhoe a lot of times on the pond. We go out and dig out the pond and get test pits and measure the clay liner thickness. Make sure it's there. Here's another pond in here. We get a backhoe and just dig out and get the test pits for the clay liners. This is another job that the detention pond, they put a clay liner in and they let it sit for like 9 months. The soils were very clayey, but it just sat in the had an outfall there. The soil started having shrinkage cracks and it started losing water. So we were hired to go out there and to make sure there is clay liner there. The pond was built in 2003. It was about 15 foot deep. That they're supposed to have a 2 foot of clay liner. And they're supposed to have 2 foot of clay liner, compact 95% standard proctor density and moisture content 1 to 3%. Nobody did any testing. Sat empty almost for a year and developed shrinkage cracks. The initial geotechnical report for the pond, we did 3 borings there. He showed clay all the way down to about 14, 15 feet. These are all fat clay. Below that, it was sand. Here's the clay all the way down to 13 feet. You got a PI of 46, PI of 56. So there was fat clay. Below that was sand. So objective was to find out the clay liner types, clay liner thickness, compaction and density, and moisture content. So we sent our portable rig because we couldn't use a big rig inside the pond. So we used an ATV rig like this and used one of our portable rigs. Went out there and started doing sampling on the bottom of the pond. Drill holes and got samples to run density tests and moisture. On the slopes in some areas that they had access problems, we actually used to do hand drilling and getting samples like that. Bang the samples in. And to get the clay liner thickness on the slopes, we had to almost use like a little beaver drill and make a big hole, and so that you can measure the clay liner thickness. It's 24 inches. To verify the clay liner was 24 inches of fat clay, which all passed. All the thicknesses passed. Measured clay liner was 2 foot. Proctor test results. We ran a proctor test with a liquid limit of 65, PI of 44. The clay liner material was fat clay. We ran density tests. We got the dimensions, the height, the diameter, weigh it, run density test results for these different borings, B1, B2, B3, B8, B9, depths 1 to 2 feet. Moisture content was 35. Optimal moisture was 21. The soils were pretty wet. Dry densities were 88, 91, 90. Design density was 95 pounds per cubic foot. So densities fail. Obviously, if you have high moisture soil, your density is going to fail. Compaction and density, moisture did not meet project specifications. The soils were very wet. A typical clay liner specification is, basically general, provide materials, labor, equipment, testing necessary to construct and compact clay liner in a wet pond, as shown on the plans and the specifications. It should have a low permeability soils, preferably soil with a permeability of maximum permeability of 10 to the minus 7 centimeter per second. Submittal, material sources, where you're getting the materials, gradations, adiabatic limit, make sure your liquid limit greater than 50, proposed construction methods, quality control, density tests, moisture content test, hydraulic conductivity test, permeability. Clay liner requirement, clay content greater than 30%, fine, passing number 200 sieve, 65%, plasticity index, liquid limit greater than 50, PI greater than 30, organic content, 2%, maximum particle size, 2 inches, free up topsoils. Soil should be non-dispersive. If your soils are sandy, you can add bentonite to it. Minimum 5% bentonite to the sandy soils to make it impermeable. Construction requirements: excavate and shape the pond, remove the loose materials, scarify top 6 inches, compact 95% standard Proctor density. Minimum finished thickness should be 24 inches. Place in 6 to 8 inch loose lifts, compacted 95% standard Proctor density. Compact with a sheep's foot or steel draw roller compactor. Ensure continuous bonding within the lifts. Disc or scarify lift if surface is dry. Moisture conditioning: if add water if your soils are dry, you want to compact to the width of the optimum. And do not place clay liner on a frozen ground. Key trenches, sometimes on these clay liners you put key trenches at the perimeter to prevent leak. Fill the trenches with the clay material and compact it. We want a soil with a permeability that 10 to the minus maximum permeability of 10 to the minus 7 centimeter per second. You got to run permeability tests to verify to make sure it passes the permeability. Permeability should be less than 10 to the minus 7 per centimeter per second. Quality control: run density tests one every 2,500 square foot per lift. Perform nuclear gauge. Rework compact pale areas to meet criteria. Run Atterberg PI test one every 100 cubic yards of a clay liner clay. Proctor test one per bar source material or material change. And run a permeability test as needed. Contractors should maintain and submit test logs, daily construction reports, and as-built thickness verifications. Protection of the clay liner: do not allow construction traffic on a finished clay liner. Place 6 to 8 inches of protective soil cover immediately after acceptance. If the clay liner is going to sit, you can put some, clay on top of it. But, most people, nobody does that. As long as basically you put your clay liner, you need to fill up the pond with water. Protect exposed surfaces from drying, cracking, or erosion. Put grass, sod in there, cover it up. Install erosion control matting on slopes as required. Compacted clay liner should be measured by cubic yard or square foot. Payment includes materials, placement, compaction, moisture conditioning, testing, and all the incidental work. So we run into problems if you don't do a good job on the clay liners. Original contract, if you got to go back, redo the clay liner, it's going to cost a lot of money. That's the end of the program. Please send me pictures of the projects. If you got some good pictures of clay liner construction, I like that. This program is going to be on YouTube. There's going to be a poll here. See what you all think. If you think I need to add something to this. So let me know if you should add something to it or you got some thoughts. Shoot me an email. I would appreciate it. If you need to reach me, this is my email, de@geotecheng.com. My number is 713-699-4000. We're going to have several upcoming programs. If you registered for this, you will get notice of that. I got the one that's coming up January 15th on design of bridges using the new TxDOT design manual. You're going to get 1 hour PDH on this. Any questions? So nobody had any questions, I guess. Questions? Yeah, we got a question here. Aerial combination soil cover over the clay liner. I mean, nobody does that necessarily, but if you want to put a soil on top of the clay liner, put some more clay in there, fat clay. So with a liquid limit greater than 50, PI greater than 30. So that would be good material to put on there. Any other question? Is there an optimum design for a detention pond slope? Well, if you got fat clay, typically in Harris County, Galveston County, Rosario County, Montgomery County, if you got, hard fat clay, you can go 3-to-1 on slopes with erosion protection. If you got sandy soils, you got to go 4-to-1 on the slopes, 5-to-1 on the slopes with good grass erosion protection. David, was the pond ever fixed? Yeah, what happens was we went in there and brought in 2 foot of clay liner material and put it on top of, we scarified the existing soil out there on that pond and put 2 foot of clay liner on it, filled up with water immediately, and nobody has called me, so I guess it's holding water. Can you install a clay liner in an existing detention pond that is leaking? Yeah, you can put clay liner in the existing ponds that are leaking. I've heard of there's some materials that you can put it into water that just kind of seals the leak. I've never used it, but I mean, if you got an existing pond that's leaking, you're gonna have to, pump the water out. And depending on the volume, you may have to go out there and take out top 2 feet of the soil and put a new clay liner in, or if you can just put 2 foot of clay liner on top of the existing material. But again, we want a soil with a liquid limit of greater than 50, PI greater than 30.